Good afternoon. Thank you so much for joining us today for a conversation about business intelligence for natural resource conservation and how we can do all of that by being even more sustainable in our compute. Benoit and I are excited to speak with you. We're going to be talking about AWS's broad commitment to sustainability, not only in our technology, but also through our technology. We're also going to be discussing a couple of specific use cases around natural resource business intelligence, around forests and oceans. And we'll also be looking at innovation for machine learning at the extreme edge, particularly around supply chain resilience. I will then hand it over to Benoit, who will be talking about how we can reduce the carbon footprint of machine learning workloads and how we can optimize all of that along the entire machine learning lifecycle. We actually have a couple call to actions. We want to invite you into our work, and we'll be talking a little bit about what that looks like. You may have heard Adam, our CEO, this morning, reaffirm our commitment to sustainability as a company. If you know anything about Amazon, you know that we live by our leadership principles. They're not just values we put up on a wall, but they are principles by which we make decisions every single day. It's how we hire, it's how we say yes or no to different opportunities. And we're very proud that at the end of last year, this new leadership principle was added to our portfolio. And it basically says that we are committed to being responsible not only to the primary, but also the secondary effects of everything that we do and ensuring that we leave the world better than we found it. And so what we're talking about here today is really about how we do that not only in our technology, but through our technology. One of the ways that Amazon is doing this is through the Climate Pledge, which we are proud to have founded together with Net Zero. It is a commitment to beat the Paris Accords by 10 years. And we're on track to do that because we know that it is absolutely urgent that we heed the call of our scientists who say that we have to limit global warming to 1.5 degrees Celsius by 2050 at the latest. And there's no one company or one organization that can do this on their own. And so we're very proud to have catalyzed as a company really what is a movement that is bringing together many companies from around the world. And we have stated that we want to be together net zero by 2040 and also make sure that our operations are 100% renewable at the same time by 2030. We've had over 375 organizations from all over the world take the Climate Pledge to date. It's growing. And this is as of September 2022. And these signatories are represented by 34 countries and 54 industries. We've also put our money where our mouth is, and we're actually investing in companies that are helping us to fulfill our Climate Pledge obligations. We've started with a $2 billion investment in this fund, and we invest in visionary companies whose products and solutions will facilitate our move toward the kind of carbon neutrality that the Climate Pledge is all about. The funds invest in companies in these areas listed here. And if any of you are in companies like these, we would love to talk to you about how you might get involved with the Climate Pledge Fund. We are also taking very seriously how we become increasingly sustainable as a company in our operations. And you heard Adam talk about some of this morning through our water pledge, ensuring that we are actually giving back more water than we are using. As of September 21st of this year, Amazon had a total of 379 renewable energy projects around the world, 117 in Europe, some in Asia, most of them in North America. And we are now the largest purchaser of renewable energy around the world. And we have projects in 21 different countries that are helping us innovate around renewable energy. We are producing more than 18.5 gigawatts of renewable energy just through some of our solar projects. This represents more than 4.6 million US households a year. So we're very excited to be innovating around energy, around water, to make sure that what we do in the cloud and through the cloud is sustainable and not just what we do through the cloud. In addition to our Amazon-wide commitments to sustainability, AWS has taken further and I think very special steps to contribute to social and environmental impact. And I'm very proud to be a part of the team that represents one aspect of that. By deploying our core engineering and field organizations, we have created a group called Global Impact Computing that develops and brings to market really what is a new class of products. We are trying to figure out a couple of things. How do we deploy, like we're going to talk about today, machine learning in new and specialized ways so that we can address, in the case of this conversation, conservation use cases? But we also think about broader climate risk and resilience, about health equity analytics, particularly through the social determinants of health, circular economy, ESG analytics, and also responsible AI. And the question that we get to ask at being part of the core of the company is how do we deploy the solutions that we have in ways that are most useful to customers in any sector, whether commercial or private sector, whose goal is certainly to be efficient as an organization or as a business and to continue to innovate in the cloud, but also to move the needle on social and environmental impact metrics. How does that what questions does that ask of us as we think about deploying the existing tools that we offer? And then secondarily, are there entirely new solutions that we might need to create, what I sometimes call impact native solutions, that might be as different to traditional solutions as on-premises solutions are to cloud native solutions? And so through our group, we're doing R&D with partners all over the world to ask these questions. How can we deploy what we have in more effective ways for social and environmental impact? And how can we create net new solutions that can actually help us to serve our customers who are trying to move the needle on change metrics in a better way? And so we're working with customers around the world to try to figure this out in these 6 areas. We're also very proud to host at Global Impact Computing the Amazon Sustainability Data Initiative, which is a very special initiative of the company. We have 71 petabytes of data in 141 data sets that host some of the world's most important sustainability, climate risk, and resilience data. We'll be increasing to touch on some of the health aspects of climate change as well. ASDI's mission is to reduce the cost and time and the technical barriers to extract insights and knowledge from very large data sets, very large and complex data sets, and to make correlations between data sets that previously haven't been made. What impact does pollution have on asthma in the case of redlining in urban United States? How can we think about flooding and epidemiological modeling in global South countries? These are the questions that we would like to be able to ask and answer, not only through the technical capacity that ASDI allows us to have, but also through the human capital, the talent that we're able to develop as now these solutions are available around the world where they previously haven't been. So through ASDI, we also provide cloud grants to create access to this data and compute, as well as to build this capacity. And at the end of our conversation today, we'll give you a chance to get some information about how you might be able to apply for some of those. ASDI currently works with scientific organizations like NOAA, NASA, the UK Met Office, who's here with us this week and we'll be talking about in other contexts, the government of Queensland in Australia. And we help them identify, host, and deploy key data sets on the AWS cloud, including weather observation, weather forecasts, climate projection data, satellite imagery, hydrological data, air quality data, and ocean forecast data, all very relevant to what we're going to be talking about today in terms of conservation. Something that we're really proud of, and I know Benoit is going to talk more about this, and you heard Adam talk about this today in his keynote, is that we're actually innovating in the silicon as well, in the very tools that we use to think about the ways that we can innovate compute for these solutions. And so we care about the cloud compute for sustainability, but also the sustainability of cloud computing itself. And so we have improved our power efficiency, for example, in the case of Graviton and Inferentia, by removing the central uninterruptible power supply, or UPS, from our data centers and integrating small battery packs and custom power supplies into our racks. These changes combined reduce energy conversion loss by about 35%. One example of how we're building hardware with sustainability in mind is Graviton, as I mentioned, which is our 3rd generation ARM-based processor. Graviton 3 is based in Amazon Elastic Compute Cloud, EC2, instances, which are 60% less energy dependent than some of our more traditional instances. And so particularly as we think about very large machine learning workloads, we're very excited to be innovating the ways in which we do that compute so that we can not offset some of the savings that we create by helping customers with their sustainability goals by then not being sustainable in our compute itself. We're also innovating what we do through the cloud and creating opportunities for our services to actually do things that they maybe had not been asked of them in the past. In high-performance computing, for example, we're pushing the bounds of supercomputing so that we can serve very complex social and environmental impact challenges. You may have heard Adam this morning mention the work that we just finished with the Dana-Farber and Harvard research centers, where we did what is probably one of, if not the largest cloud compute runs ever on any cloud, 5.7 million vCPUs, that enabled Harvard to analyze over 80 billion molecules in a matter of days at a cost that is a fraction of traditional virtual screening. In AI/ML, we're finding ways to deploy computer vision at the extreme edge, which I'll talk about in a second, particularly in conservation. We're thinking about forests and oceans here. And we're also reducing the carbon footprint and bias of large ML models through our responsible AI work. In analytics, we're creating new kinds of data lakes that take into account a lot of what we heard also this morning around governance, around the kinds of insights and inferences that are necessary when we're dealing with very large and complex data sets that previously haven't been merged to give the kinds of insights that we want to give around climate and health, for example. And so we're creating new kinds of data lakes, new kinds of analytical methodologies to think about causal inferencing, multivariate analysis that speak directly to some of these health and climate implications. And with modeling and simulation, we're very excited to be opening up a space which we sometimes like to call human, not just human in the loop, but life in the loop. It's one thing to have a human looking at a machine and observing that interaction, but what happens when we're looking at complex adaptive systems like communities and ecosystems, the movements of entire species? That kind of very dynamic and complex systems analysis is something that modeling and simulation has done, certainly in academic centers and in a lot of our national labs. But how do we scale this and enable it almost as a service on top of our infrastructure? Those are questions that we're very excited about, and particularly thinking about agent-based modeling and ways that that can drive better impact. And so what's exciting about all this is that even though philanthropy and ESG and corporate social responsibility are very important motions for companies like Amazon, what we're doing here isn't just philanthropy. It's actually an investment from the core of the company that drives the core of our engineering and our business strategy into the space, because we think that the social and environmental challenges that we face are too important for the core market dynamics at play not to be taken into account. And today, we're particularly excited to be talking about machine learning for sustainability. We are deploying various aspects of our stack, both SageMaker, as Benoit will talk about, as well as self-managed machine learning, to think about particularly impact-native, impact-specific ways to drive ML for these use cases. And these give us opportunities to deploy diverse machine learning approaches to solve the kinds of complex problems that I've mentioned. So let's dive into the core use case for today with this kind of context, which gives you a sense of the broad scope of what we're trying to do in social and environmental impact. So in conservation, we're using machine learning to ensure that we protect natural habitats and our sibling species in ways that are sustainable and that leverage the kind of insight we can get from the cloud and from the massive amounts of data that we can host and analyze in the cloud. And we're doing that in a way that improves not just the lives of these ecosystems and species, but also in ways that help us think about the resilience and sustainability of natural resource supply chains. And that's why I think the conversation today is so exciting, because we're beginning to think about with you what business intelligence looks like when what we're trying to drive is this kind of natural resource conservation. And so in many ways, this allows us to think about machine learning as a kind of wedge where the critical last mile challenges emerge in terms of figuring out what we do when we are in the deep edge of the middle of the ocean or in the middle of forests, as we've talked about. And so for us, this first mile challenge is an opportunity to deploy business intelligence to help you, our customers and partners, steward natural resources to benefit from accurate and relevant, timely data, so that we can design and adjust resource verification and tracking and management strategies of all kinds of natural resources. And the need for this kind of actionable insight is particularly acute in remote environments like oceans and forests, where so many of our natural resources reside. So first, let's look at oceans. We are excited to be developing a portfolio of ocean-focused solutions to protect one of our most critical resources and one of our most impacted resources as we face climate warming and climate change. Some examples of what we're doing. With Martech, the largest provider of fisheries electronic monitoring services in the world, we are working in the deep Pacific, particularly with tuna fisheries, one of the most complex sustainability questions in fisheries. And we're using AWS data, machine learning, and computer vision services to create visibility into the full supply chain of sustainability. What's so exciting about working at a place like AWS and Amazon is that we get to think about the computer vision and edge applications of machine learning that analyze a catch as it comes out of the boat, how it's processed on the boat and on the shore, all the way to a Whole Foods or Prime shelf. So imagine the ability to have real visibility into the sustainability of fish or any other natural commodity, all the way from its source to where it touches us as consumers. That's very exciting for us to be able to think about that whole stack. With OSearch, we're using modeling and simulation from data sourced from tagged sharks to understand shark behavior and particularly that behavior in the context of climate change and overfishing. With the Nature Conservancy, an amazing partner of ours, we are developing what's called an animal biosecurity platform that has machine learning-enabled camera traps and platforms to detect and alert the presence of predatory invasive species using SageMaker and edge devices. This is now deployed in the Santa Cruz Islands, and we're beginning to deploy it in Hawaii as well. And finally, with SkyTruth, we're using satellite data and machine learning to understand patterns in Landsat imaging that indicate ocean pollution by commercial vessels, as well as illegal bilge dumping and other anomalies in the ocean before they spread. The electronic monitoring data architecture that we're building, particularly with the Nature Conservancy and Martech, and this is an example of what they're doing with this architecture, enables us to work with the data that's captured from IoT devices to provide the business intelligence that we've been talking about, and gives us increasing insight into this first-mile natural resource operation challenge. And this is the kind of work that we're doing with our partners to co-design the kinds of architectures that are going to be most meaningful for them. So these are really exciting opportunities for us to drive innovation at the very edge by integrating AI/ML, IoT, and flexible data structures to work backward from social and environmental impact needs and allow us to develop impact-native, impact-relevant solutions that both meet the need of our customers and create opportunities for us to solve adjacent problems, in this case, in supply chain, in natural resource management more generally. Now, I'll finish before I turn it over to Benoit by speaking briefly about what we're doing in forests, another analogous use case. Machine learning, IoT, and analytics are also helping customers steward forest resources, a critical foundation, obviously, of our global carbon reduction strategies. With the World Wildlife Foundation, we are augmenting their Forest Foresight platform, which they built in collaboration with Deloitte. We're augmenting that with machine learning and HPC-powered simulation to improve anti-logging and analytics, particularly to inform policy design. With Tesselo, a very interesting Portuguese-based ML-powered satellite data modeling company, we're building a digital twin of the Earth at 1 millimeter resolution to measure the green forest density in order to allow us to validate carbon credits. So this is a way in which we can use natural resources to actually create entirely new capital mechanisms and use machine learning at the edge to validate all of that. And with the First Street Foundation, we're very excited to be doing some of the work that we did with the Dana-Farber Center, which you heard about earlier today around cancer research, and instead use high-performance computing and million-plus core runs to, for the first time ever, provide forest wildfire risk data, as well as flooding data at the level of properties, and then linking that to health. So for the first time ever, we'll be able to analyze the risk of climate change in terms of wildfire and flooding in a way that each of us as individual homeowners might be able to benefit from. So the extreme edge of both ocean and forest conservation use cases allow us as a company to innovate reference architectures like this that take into account data, analytics, machine learning, and it helps us to inform the development of conservation-relevant IoT and hardware as we think about how we can ruggedize different devices, think about 5G, and the analytics that can undergird the data that they provide for us. There are many other commodities in dire need of more sustainable and transparent analytics. And so the lessons that we're learning together from oceans and forests are relevant far beyond these use cases. We can think about anomaly detection in many other areas in commodities. And so we're excited to be working with customers and partners to innovate about these, and we're excited to do that with you. And what's exciting is that we're not only helping you figure out how to be more sustainable in your conservation efforts, but we're also working very hard to innovate how we as a company actually change the way that we think about our hardware, our infrastructure, and our compute instances to make sure that they are as sustainable as possible as well. So we're just scratching the surface of what cloud computing can do generally and how it can drive social and environmental impact use cases like these. And so the promise of natural resource business intelligence is that we can co-develop with you new approaches to using machine learning and related technologies to serve these really critical needs. So with this, I'll turn it over to Benoit, who will help us to dive much more deeply into ensuring that our compute itself is as sustainable as possible.
Yeah. Thank you, Nelson. As we've just seen, machine learning is a powerful tool to decarbonize the planet and to preserve natural resources. But it also questions how to build AI systems that are sustainable and benefit everyone. How to design AI systems that have a positive net impact. So the reality today is that machine learning are becoming bigger and more complex. Since 2012, the compute used for large AI model training runs has been growing by 300,000 times, and the carbon emissions have grown accordingly. This is a trend that is called red AI. Red AI is buying stronger results by using massive compute and prioritizing accuracy over efficiency. So if we don't want to make the energy requirements of AI to become enormous, then we must make concerted efforts to improve efficiencies. And that's what we are going to cover today in this second part of the session, how to optimize machine learning workloads for sustainability. So the first and most important decision you can make is to build, train, and deploy your machine learning workload in the cloud. Because according to 451 research, AWS can lower the carbon footprint of average on-prem data center workloads by nearly 80% today, and up to 96% once AWS is powered with 100% renewable energy, which we are on a path to be by 2025. And where do these energy savings come from? So 61% of the carbon emission reduction comes from more efficient servers and higher server utilization. 11% of carbon reductions come from more efficient data centers facilities, and 17% come from reduced energy usage and renewable energy. And once your machine learning workload is in the cloud, then sustainability is a shared responsibility. So AWS will design buildings, rooms, and servers and take care of it from construction to recycling. AWS will purchase the energy and ensure that the energy and also other resources like water for cooling are used efficiently. And AWS service teams will run managed services and optimize them for sustainability. And you, as a customer, your responsibility is to make architectural decisions, is to select and use the services, and to determine which code is running and how efficient it is. Over the last years, we've published 5 pillars of the well-architected framework, and they capture best practices for operational excellence, security, reliability, performance efficiency, and cost optimization. And their goal is to support you delivering great products. But now, with the climate crisis, we have to deliver sustainable products. And that's why we introduced the sustainability pillar. And for us, it's super exciting because it means that sustainability is as important to a successful workload as performance or cost or security. So once you are in the cloud, then your most important decision you can make in terms of sustainability is to select the region where you will build and train and deploy your model. For a machine learning model such as BERT, which are trained on multiple GPUs during weeks, this single choice can avoid emitting several hundreds of kilograms of CO2 equivalent. So how to choose the right region? You can select a region near Amazon renewable energy projects, like you have on this map. Or you can select regions where the grid has a published carbon intensity that is lower than other regions. And you can use online tools like electricity maps for that. Or you can use one of the 13 regions, we just published the list, one of the 13 regions that were powered with more than 95% of renewable energy in 2021. And they are mainly located in North America and Europe. But you may ask, why should I optimize my workload if AWS will be powered by 100% renewable energy by 2025? And the first answer is that we want to save energy. Because even if the energy is renewable, it takes resources to build a wind turbine or a solar panel, right? And cloud resources are physical. They have what we call embodied carbon. That is the carbon emitted during the manufacturing, transportation, and disposal of a device, such as a server, for example. So we want to optimize the use of these physical resources. So what's your goal? What's your objective function when optimizing for sustainability? First, you want to maximize the utilization of your cloud resources. And you want to maximize the CPU efficiency. And you want to eliminate idle resources. Or you want to minimize data processing and data storage. This is the typical machine learning lifecycle. In the business goal phase, you want to have a clear idea of the problem and the business goal and the business value to be gained by solving this problem. In the machine learning problem framing phase, then you have this problem and you want to frame it as a machine learning problem. So what is observed and what should be predicted. In the data processing phase, you are collecting your data, storing it, processing it, and you are converting your data into usable format. Then, once you have your data, you can start building your model, and you can start training, tuning, and evaluating your model. And once it's ready, you deploy it to production, and you can start making predictions and inferences against this model. And when it is in production, you want to monitor your model to ensure that it is maintaining the desired level of performance. So when we want to optimize a machine learning workload for sustainability, in the business goal phase, we want to measure the workload impact and its contribution to the overall sustainability goal of the organization. So that means how much data will we have to collect? What will be the impact of training the model? And how often will we have to retrain this model? And most importantly, what is the impact resulting from customers using this model in production. So the goal here is to ask questions in planning phases and to set goals. Really, you should consider sustainability as one of your non-functional requirements, just like security, performance, or cost. Then, in the problem framing phase, the first question you should ask is, do we need a custom model? Because many times, customers don't need a custom model. Many workloads can use AI services managed by AWS, like Poly for speech or recognition for computer vision. And when you use these services, it means that you won't need the associated resources to collect and store and process the data, and then to build, train, and deploy your model. But if adopting a fully managed AI service is not appropriate in your context, then evaluate if you can use pre-existing datasets, algorithms, or models. For example, in Amazon Marketplace, you can find more than 1,400 ML-related assets that customers can subscribe to. Or you can use a pre-trained model available on Amazon SageMaker Jumpstart or Hugging Face, for example. And using this pre-trained model from third parties means that you can reduce the resources you need for data preparation and model training. In the data processing phase, to avoid processing duplication, consider using publicly available datasets, like those available on AWS Data Exchange or open data on AWS, including Amazon Sustainability Data Initiative that Nelson mentioned. Because when you use this curated dataset, you can avoid duplicating the compute and storage resources needed to collect the data from the provider, and then store the data, organize it, and clean it. Only provision resources when work needs to be done. For example, if you are using AWS Glue or AWS Step Functions for data ingestion and data preprocessing, you are not maintaining a compute infrastructure 24/7. To minimize data movement across network, compress your data, store your data close to your producers, and train your models close to your data. In terms of storage, you can use a feature store like Amazon SageMaker Feature Store to reduce dataset duplication and to avoid processing multiple times the same data for different teams or different projects. Using formats like Apache Parquet or Apache Orc can help you save up to 87% on your storage compared to CSV, for example. In terms of storage options, we should think strategically about the type and tier of storage that we use, because sometimes data needs to be accessed very fast and often. So it will require more energy because the objects will be immediately available. But sometimes the data is never used again after it has been processed or after the model has been trained. So if you can make trade-offs on durability, availability, or response time, then you will find you will be able to move your objects down this chain, and you will find more sustainable options that use energy more efficiently. And we have lifecycle rules to automatically purge or tier or delete your data according to your business needs. Model building. You remember Red AI, right? If we focus only on the model accuracy, then we ignore the economical, social, and environmental impact of reaching this accuracy. So try to make trade-offs between accuracy and carbon footprint. Try also to find simplified versions of your algorithms. For example, DistillBERT, it's a distilled version of BERT. It has 40% fewer parameters. It runs 60% faster while preserving 97% of BERT's performance. Avoid training a model from scratch. So for that, you can use techniques like transfer learning or incremental training. Right-size your training environment with metrics from CloudWatch, like CPU or GPU usage, memory, and disk utilization. Prefer Bayesian search over random search, because Bayesian search typically requires 10 times fewer jobs than random search, so it will require 10 times less compute resources. And use a debugger like Amazon SageMaker debugger, because a debugger can help you stop a training job as soon as a bug is detected, like, for example, overfitting or saturated activation function. So you won't use the unnecessary compute resources. So, of course, optimizing for sustainability means selecting the most efficient hardware for your training jobs and inference jobs. So do right-sizing. Select the right instance type. Select the right instance size, the right amount of memory, the right amount of GPU, and so on, but also the right processor type. And AWS offers purpose-built silicon for machine learning. So for training, we have Trainium. That is the most energy-efficient AWS processor for training. And for inference, we have Inferentia. And the new generation of Inferentia instances has been announced this morning. So Inferentia has 50% higher performance per watt than G4DN instances. And if you are running inference on CPU, consider using Graviton3 because it uses 60% less energy than comparable EC2 instances, like Nelson mentioned. When deploying, training job process hundreds of data samples in parallel. When inference jobs usually process one single input in real time. So it requires a small amount of GPU compute. And with elastic inference, you can attach just the right amount of GPU to any kind of EC2 instance, or SageMaker instance, or ECS task. Compile your model with open source compilers, or compilers like Hugging Face Infinity or SageMaker Neo. Because when you are compiling your model, you are deploying more efficient models. And that means that you will need fewer resources for inference. Sharing endpoint resources is more sustainable and less expensive than deploying one single model behind one endpoint. You can save up to 90% of your costs and the associated carbon emissions. In order to right-size your inference environment, you can use CloudWatch metrics, and you can also use SageMaker Inference Recommender. And if your workload has intermittent or unpredictable traffic, consider auto-scaling inference endpoints or serverless inference that will automatically scale in and out your resources. So you don't have idle resources. Nelson mentioned inference at the extreme edge. And it's true that inference at the edge, in terms of sustainability, could be an interesting option because it avoids sending data over the wire for inference in the cloud. So significant gains in sustainability can be made with no measurable impact on uptime, availability, or response time. So try to negotiate impact-friendly SLAs. For example, if your users can tolerate some latency, deploy your model on asynchronous endpoints, because asynchronous endpoints will scale the instance count down to 0 when the endpoint is not processing requests. If your users can tolerate some latency in the event of a failover, then don't provision extra capacity. In the event of an outage, SageMaker will automatically attempt to distribute instances across availability zones. And when you don't need real-time inference, use Amazon SageMaker batch transform, because unlike persistent endpoints, batch transform clusters are decommissioned when batch transform jobs finish. Because of model drift, because of robustness, because of new ground truth data being available, machine learning models usually need to be retrained. But instead of retraining arbitrarily, monitor your workload in production. Automate the model drift detection, and only retrain your model when its predictive performance has fallen below defined KPIs. So, as a summary, yes, machine learning models are becoming more complex. They are requiring more energy. But, and Nelson explains that, AI is a fantastic tool for mitigation of the climate crisis and the preservation of natural resources. So, as builders, it's our responsibility to develop sustainable machine learning models and to use AI sustainably. It's our responsibility to reduce our energy consumption and to use as few cloud resources as we can, but for the resources that we use, to maximize their utilization. So, as a call to action, start building and experimenting your sustainability project with Amazon Sustainability Data Initiative. And we have promotional credit programs to encourage applications related to the usage of SD datasets. Learn how to reduce the carbon footprint of your machine learning workloads. So ask questions about sustainability in your planning phases. Set sustainability goals. Consider sustainability as one of your non-functional requirements. You have resources online also to learn how to optimize for sustainability. And you can also identify a machine learning workload and start a well-architected framework review based on sustainability with a solution architect. We have other sustainability breakout sessions at reInvent. We also have sustainability workshops and chalk talks. So that's it. Thank you very much. Please don't forget to complete the session survey on your mobile app. And Nelson and I are here for your questions. Thank you very much.